Assalamualaikum. Today, my group will present about our assignment group. My group member is Amza Azir bin Amruddin. The second member is me, Muhammad Aiman Hakim bin Ramli. And the last member is Muhammad Idham Yusuddin bin Ibrahim.
Okay, so for the introduction, in analyzing a circuit using Kirchhoff's circuit law, one can either do nodal analysis using Kirchhoff current law, KCL, or mesh analysis using Kirchhoff voltage law. Nodal analysis is a method of determining the voltage between nodes point where element or branch connect in an electric circuit in terms of the branch current. Nodal analysis write an equation at each electrical node requiring that the branch current incident at a node must sum to 0. The branch current are written in terms of the current node voltage. Next, Ohm law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Introducing the constant of proportionality, the resistance one arrive at the usual mathematical equation that describe the relationship. Lastly, in electronics, a voltage divider, also known as a potential divider, is a passive linear circuit that produces an output voltage Vout that is a fraction of input voltage Vin. Voltage division is the result of distributing the input voltage among the component into a component of the divider. A simple example of voltage divider is two resistor connect in series with the input voltage applied across the resistor pair and the output voltage emerging from the connection between them.
So for the solution, we find this solution we have used Kirchhoff voltage law. So we have to apply KVL at VA. So we will get equation Vs minus VA per 1 equal to VA minus VB per 3 plus VA minus 0 per 4. So this is our first equation. Then we have to apply KVL at node VB. So VB is I3. The current flow at 3 ohm resistance equal to current flow at 2 ohm resistance minus current flow at 1 resistance. So we know that current flow at 2 ohm resistance is 3 ampere, and current flow at uh, 1 ampere is 1 ampere. So we will 3 ampere minus by 1 ampere. So we will get the current at 3 ohm resistance is equal to 2 ampere. So from the equation we know that the current at 2 ohm resistance is 3 ampere. So we'll use Ohm law. Ohm law that at 2 ohm resistance, and the equation will be VB minus 0 per 2 equal to 3 ampere. Then we do an algebra. Then the final answer we get VB is equal to 6 volt. So we return to KVL at node VA. So we have find at VB that current at 3 ohm resistance is 2 ampere. So we will use Ohm law again to find voltage. So we will get VA minus VB per 3 equal to 2 ampere. Then enter the value of VB that we have calculated. So we will get the equation VA minus 6 volt per 3 equal to 2 ampere. Then we do algebra. The final answer will be VA equal 12 volt. Is voltage at node VA. Then we have find the value of VA and VB. Then we enter the value at first equation at VA. So we input the value of VA and VB. We will get voltage supply minus 12 per 1 equal to 12 minus 6 per 3 plus 12 minus 0 per 4. Then we do algebra. Final answer we will have voltage supply equal to 17 volts.
Okay, for simulation task 2, we must doing a simulation by using circuit task 1 to prove the result we get from task 1. Okay. For do this simulation, we are using fast start. The result we get from task 1, Vs is equal 17 volts when 3 ampere current through downward to ohm resistor. To the simulation, we put 17 volt at Vs at voltage source. To prove it, we put voltmeter parallel with Vs. And we also put ammeter to show that there are 3 ampere current downward to 2 ohm resistor. Then we run the circuit. We can see that the Vs is 17 volt and the current through the 2 ohm resistor is 3 ampere. This a proof that the result we get from task 1 is correct.
Okay, the solution is first we have assumed R1 equal to 100 ohm. So enter the value of R1 to at voltage current voltage divider rule. Okay, then after we enter, we will get R2 over 100 ohm plus R2 30 volt equal to 5 volt. So we do algebra, and the final answer we will get R2 equal to 20 ohm. For the question B, find the power dissipate, maximum power dissipate at R1, R2. So to find power, we have to V voltage power 2 over R. So enter the value as. Okay, enter the value. We will the final answer. We get power dissipate at resistance 1 is 6.25 watt, and power dissipate at resistance 2 equal to 1.25 watt.
Okay, for discussion, from what we observe, the value we get from task 1 is same with the simulation we do. There are several techniques we use to complete all these tasks, such as Ohm's law, nodal analysis, and voltage divider rule. For the simulation, our group used fast start to complete it. The result we get from this assignment is proof that we have learned to calculate the task by using theoretical method. For task 1, we are using Ohm's law and nodal analysis to get Vs when 3A current run downward through 3 ohm resistor, and we prove it by do simulation at task 2. Then task 3, we using voltage divider rule to complete it, and we using R1 is 100 ohm. And by using voltage divider rule, we get R2 is 20 ohm if the voltage display is 5. Next, for the maximum power dissipated by each resistor, we get 6.25 watt for R1, while R2 is 1.25 watt.
Okay, in conclusion, the voltage divider or network is a very common and useful circuit configurating allowing us to produce different voltage level from a single voltage supply, thus eliminating the need to have spread power supply for different part of a circuit operating at different voltage level. Nodal analysis involves solving voltage with the use of Kirchhoff current law. This is done by first identifying all the necessary node in the circuit, including a reference node. In the nodal analysis, everything is expressed in current discrete that one by using Ohm law and considering potential different in node between two voltage. Applying Kirchhoff current law equation will be formed. The number of equation formed in one minus the total node, including a reference node, and this is simultaneous equation can be solved using a matrix. Okay, so lastly, we can know that Ohm law deals with the relationship between voltage and current in an ideal conductor. This relationship states that the potential difference across an ideal conductor is proportional to the current through it. The constant of proportionality is called the resistance R. Thank you. That's all from us.